Welcome to Learning with Philemon. In this video, we will be looking at the different gas laws. In the previous videos, we learned that a gas that behaves ideally follows the equation PV equals nRT. For more details on this equation, watch these videos. Rearranging this equation, we get PV divided by T is equal to nR. If we have a gas in a container, as seen in the diagram, and do not let any gas escape, the number of moles N of gas does not change. Remember that R stands for the gas constant and also does not change. From this equation, we can derive the following equation. P1V1 over T1 is equal to P2V2 over T2, where 1 indicates the initial and 2 indicates the final condition of the gas. This equation, called the combined gas law, shows us that the pressure P, volume V, and temperature T of a gas are all dependent on each other. If the temperature decreases, T2 is less than T1, then P2V2 must also decrease. This might mean the pressure or the volume decreases. If this did not happen, then these two fractions would not be equivalent. Other gas laws are derived from this gas law, as we will see in the subsequent slides. In Charles's law, we keep the pressure constant, therefore P1 is equal to P2. This equation is simplified to V1 over T1 is equal to V2 over T2. Another way to think of Charles's law is to rearrange the PV equals nRT equation to V equals nRT over P. As N, R, and P are constants, we can simplify this to V is proportional to T. As shown in this graph, as the temperature increases, the volume increases. The slope of this graph would be equal to nR over P. Note that the temperature must be in Kelvin. At 0 Kelvin, an ideal gas is assumed to take up no space. We know that this is not the case for real gases. To explain the graph, we need to think that at higher temperature, the particles move faster on average. If the volume is not increased, the particles will collide more frequently with a container's walls, increasing the pressure. We will see an animation at the end of this video demonstrating this. Now let's look at Gay-Lussac's law. In Gay-Lussac's law, we keep the volume constant, therefore V1 is equal to V2. This equation is simplified to P1 over T1 is equal to P2 over T2. Rearranging the PV equals nRT equation so that pressure is the subject, we get P is equal to nRT over V. As N, R, and V are constants, we can simplify this to P is proportional to T. As the temperature increases, the pressure increases. This is because the gas particles are moving faster on average and therefore colliding more frequently with a container's walls. Note that at 0 Kelvin, the gas particles would not be moving, and thus the pressure would be 0. Now let's check out Boyle's law. In Boyle's law, we keep the temperature constant, therefore T1 is equal to T2. This equation is simplified to P1V1 is equal to P2V2. Rearranging the PV equals nRT equation so that pressure is the subject, we get P is equal to nRT over V. As N, R, and T are constants, we can simplify this to P is proportional to 1 over V. Pressure and volume are inversely proportional, as shown in this graph. As the volume increases, the pressure decreases. If we want a linear graph, we can plot pressure versus 1 over volume. The slope of this graph would be equal to nRT. Now let's check out an animation by PHET that helps us visualize these concepts. In this animation, we have gas particles in a container. We can explore the different gas laws by keeping different variables constant. If we keep the pressure constant and increase the temperature, the volume of the gas and the container increases. Note that the particles move faster on average and collide more often with a container's walls at higher temperatures. If we keep the volume constant, the pressure increases with increasing temperature. You can see this in the pressure in kilopascals here. Finally, we can keep the temperature constant. If we decrease the volume, the pressure increases. I recommend you play around with this animation to get a better grasp of the concepts. In this final slide, we have all the gas laws summarized. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.